Hi girls, good morning. Today we are going to review chapter 7. So first of all, before I just share with you the extra practice, I would like to review with you what did we do in this chapter. In the first 4 lessons, we learned some properties and let me list these properties for you. So we had first of all, in the first lesson, we had zero powers. So anything raised to a zero power, it will be directly equals to 1. Also, we had, if we have m to the power negative m, for example, you are going to move this one down and say that is 1 over m to the power a to the power m. So a to the power m. We also said if we have the same base, we are going to add the powers. For example, if we have a to the power m and between the multiplication a to the power n, so that is equals to, since they are same base, you are going to add the powers. So a to the power m plus n. Also, we learn if we have, for example, a to the power, a power raised to another power. For example, if we have a to the power m, it's also raised to another power, which is, well, let's say it's n. So that is equals to a to the power m n. So we had some examples also before. Also, we discussed about the division. If we have a to the power m, for example, over a to the power n, if we have the same base and we are dividing the same base, we are going to subtract the powers. So that is a to the power m minus n. Also, we had in this chapter, if we convert between a radical symbol, if we have, let's say, m, and inside we have, for example, n, we said that that will be a to the power, that will be a to the power n over m, which is what we can say m. This is the m, it's represent the degree of the root, so it will be in the denominator of the fraction that written in the exponent. So that will be, I can rewrite this one, a to the power n, all this to the power 1 over m. You can also change the order for these. You can write 1 over m inside and n outside. So that's what we just discussed, the quick and fast, the properties that we learned. Let's start our revision. So I'm going to share with you now the practice sheet as usual. So I'm going to solve with you some questions and some exercises. Make sure that you try them. Take your time. Once you try them, then see the answer from what I'm doing with you. So that will be for this one. 2t. So that means you can here distribute the power. I forgot to say something about distributing the power in my board. So let me share with you my board again. I hope it's not erased. Yeah, great. So we also said if we have A, let's say times B, all this to power, for example, M, we are going to distribute the power. So that will be a to the power m times b to the power m. Also, we can do that with division. I'm sorry, my handwriting, it's not much organized because I'm writing by mouse. So a over, if we have a over b, all this to the power m, we can distribute a to the power m over b to the power m. You have to distinguish the difference between this one and this one. That is same base and different powers. So we are subtracting them. That's how we simplify them. While here we have different base, but all this raised to the same power. So that's why we have to do that. We can distribute the power. So that's what we learned in the first three lessons. In the first three lessons, we learned how to simplify the exponent things. In the last part, which is lesson 5 and lesson 5 and 6 and 8, we discussed about the exponential function. We learned how to identify linear function and exponential function from table, from graph, and from equations. So let me just give you quick and fast. The exponential function form should be y equals to a b to the power x. How we graph this one? We graph it like this. When if b is greater than 1, and that is positive. If this is negative, you are going to graph it like this. But if b is less than 1, which means 1/2, which means fractions, so that will be something similar to this one. So if the expression is negative, so that will be something like this one. So that's what we discussed. Let me give you an example. For example, if we have that is y equal, let's use -1, equals to -2 to the power x. So the a is negative. So it will be, that's sorry, positive. If it will be like this. If the same as this one, but negative, so it will be like this. Now this one here, instead of having 2, that's what I mean by negative less than 1, which means y is 1/2, for example, all this to the power x. Same thing with this one. If you have y equals to -1/2, all this to the power x. So that's for the exponential function. We learned how to graph the exponential function. We said the basic thing in exponential function is just make table and then sketch the point. Depending on these things, if we have them, we can think about how the graph look like from these. If b less than 1, that means it will be something similar to this one, in case if we have mistake in our calculation. We also discussed about geometric sequence, and that's what we discussed in the last lesson. We learned how to write the explicit formula and the recursive formula, which is the main thing in the geometric sequence, which has the common ratio. It has the pattern between each two terms is a constant by multiplication or division. We also say the explicit is, or the recursive formula is A1. You are going to list A 1, which is what is the value. It could be any value which is the present term 1, and then you need to continue your work and say the nth term, which is equals to an minus 1 times the common difference. Also, we said about the explicit, an equals to a1 times r to the power n minus 1. We also learned how to write the sequence, how to write the geometric sequence into exponential function. We just convert this one into f of x and turn this one into x and so on. Let's get started our exercises. So let's start our exercises. So here we have the basic thing. Let's go back to the basic thing. So we have 2 to the power t. I'm going to flip this one first. You can distribute your power first, then flip. It's up to you. Do the way that you like. It will work with you, both of them. So t to all this to the power 6. I made it positive now. I can work with this one. I can distribute my power now. So 2 to the power 6, t to the power 6, then you just continue your work. 1 over, just do your calculation for 2 to the power 6. 2 to the power 6 will give you, 2 to the power 6 will give you 64. So that will be 64 t to the power 6. Now, I'll do this one, m, nothing to simplify it with, go step by step, m, nothing to simplify it with, so I'm going to write 5m. Now I have negative power, I must move it down to the denominator, so m will be negative 8, so it will be, sorry, 8, and this is 5. Then I need to continue one more step, or directly you can say I have the same base, I'm going to subtract the power. So directly you can say 5m power negative 3. So let me erase this one. It will work, but it's longer. So let's have the shortest steps. So that will equals to 5 over m to the power 3. Now, once you look at this one, the same base, add the powers. So that will be 4.5, all this to the power 2. Just calculate this one. 4.5 times 4.5, so 4.5 to the power 2 will give you 20.25. If you want to write this one as a fraction, because some of you, they prefer having this as a fraction, it's 81 over 4. I gave you a lot, I think, of exercises in the class. However, I gave you also mid-chapter test, so to make sure that you all okay with the idea. So here we have, look, W, there is nothing to do with this one until now. We will move it down, but step by step. We have to distribute, the power. So negative 3 outside, I'm going to distribute my power. So that will be W to the power negative 2 times negative 3. It's 6. J to the power negative 4 times negative 3. It's 12. Then, before I do anything with these, same base, add their powers. So J to the power 10. I will continue my work. Now, W to the power 6, no problem with this one. The power is positive. Then I have the same base again, j and j to the power 12 and j to the power 10. The same base, I'm going to add the powers. So it's 22. So 12 plus 10, it's j to the power 22. So that's for this one. Let's do this one also. If you notice that I have x, there is nothing to simplify with this x. There is no power. So x2, then I have n and n, same base between the multiplication. Add the powers. 4 plus minus 8, it will be negative 4. Negative 4. I have to do one more step. So x to the power 2, it's positive power, so I'm fine with this. So that is x to the power 2 over, move this down, n to the power negative 4, I have to make the power positive so I can deal with it. So that will be n to the power 4. Next, I'm going to do this one. If you have something like this, distribute your power. So m to the power 7 times 2, it's 14. T to the power negative 5 times 2, it's t to the power negative 10. So do your organization for this one. Because this one is negative, you have to move this down. So m to the power 14 over t to the power 10. And so on. That's it for this one. So this one is easy and regular. You just can say directly that r to the power 5 and g, if you have them different base, please do not do anything with the power. You just can say r to the power 5. You cannot subtract the powers here. You have to say move this up. So j to the power 3. That's what should you do. For question 15, they did not show well, but I think I posted for you the one with the answer. The one that with the answer, it will be better than this one, but I don't want to show the answer. So a to the power 6, a to the power 7. Here there is two ways. You can subtract these powers first, since they have the same base, then distribute your power, or you can just directly distribute your power, and because if it's negative, you will flip. Let's subtract these two powers first, then do a to the power. So that's 6 minus 7. 6 minus 7, it will be negative 1. All this to power negative 3. So that is equals to a to the power 3. That's why. That's it, because I multiply these two powers. So for this one, first thing first, and this is easy definitely, that's why I skipped some of them. So here I will distribute the power. It will be 2 to the power 3. T to the power 5 times 3. It's what? 15. Over 4. T to the power 8. T minus 1. I will continue my work here for this question. So 2 to the power 3, it's 8. Now here I have T15. I'm going to simplify what I have in the denominator, then the 4 T and T, same base, we can add the powers because they between them by multiplication. So that will be T to the power 7. And between them multiplication. Since I have 8 over 4, between the multiplication, 8 over 4, it's 2. T and T also the same base, and between them division, so I can subtract the powers. So that is 15 minus 7. It's what? 15 minus 7, which is 8. So for this one, you don't need to worry. It's just parentheses here. Instead of all this, it's just parentheses. So here you have all of them the same base. So let's do the denominator. So we have in the denominator C5, C negative 3, which is C to the power 2 over C to the power negative 4. All this to power negative 2. You can, because these still have the same base, you can, between them division, you can also subtract the powers. Keep in your mind, once you subtract the power here, 2 minus, that's from the rule, minus 4. So it will be plus, so that will be 6. All this to power negative 2. So that will be C to the power negative 12. Then rewrite 12 down. I'm sorry, my handwriting is not organized because of the mouse, and there is no spaces between them. I'm going to solve this one with you also. I posted for you, by the way, the extra practice, which is the revision in the file section. And I posted for you also the answers, because the answers will give you the correct one. But the most important thing, girls, make sure that you try them before you see the answer. If you face difficulty, please let me know. So A, here, I have these same bases, so I can subtract the powers because I have division between them. So 2 minus 5, it will be minus 3. B, minus 7, minus 3, keep in your mind, minus 7, minus 3 will be minus 10. C, 4, minus 2, it will be C, exactly same here, thing here, but it will be 4 minus, from the rule, minus 2, it will be, this one will be plus, so it will be 6. So I'm going to raise a small thing, so I can have enough space to write. So that will be, I should move this down and this down. So C to the power 6 over A to the power 3, B to the power negative, sorry, 10. We removed the negative. B to the power 10. So basically, once you have to simplify, you have first of all, look at the expression. Do you have a power raised to another power? I mean, do you have parentheses raised and then on the top of the parentheses there is a power? If you have something like that, distribute the power. Okay, once you distribute the power, look at the numbers that you have inside. Do you have same base? If you have same base, between them multiplication, add the powers. If between them division, subtract the powers. And so on. Do the rest of the calculation for the numbers. Keep in your mind what I told you before. What I told you before about, let me raise this one so I can have space. So I told you before, if you have, for example, a to the power 3 plus a to the power, for example, 2, you cannot say that's Miss a to the power 5. Wrong. Be careful. Because between them addition, you must have between them multiplication or division. So if you have here minus or a plus, you cannot say that. That's wrong. But if you have a to the power 3 times a to the power 2, you can say that's a to the power 5. So be careful, that's a correct. If you have division between them, you can subtract them. So here we have to substitute. So substitution. All your job, I encourage you to simplify first. If you need to simplify, then do the rest of the steps. Then do your evaluation. So evaluate, which means substitute by the number that you have. T, it's given -3. There is nothing to simplify it in this expression. All this to the power m. What is m? M is given 2. So that is -3 to the power 2 is 9. Keep in your mind, if you are substituting by a negative number like this, make sure that you don't forget the parentheses. So -3 to the power 2, which is equals to 9. Now this one, I don't have anything to simplify with. I should not confuse. The base are different, so I should not simplify them directly. So it's given w, take w, which is 4. Here, just, I'm sure 100% you all excellent with this part. Just I want you to notice that the order of operation is very important. So w, which is 4, m it's given to the power 2, which is 2, times t, what is t? -3 to the power 2. So that will be 16 times 9, which is equals to 144. I'm going to do with you something like more complicated. This is exactly the same idea, but here I encourage you to move this down first, which is just say m to the power. You can just multiply this power, tz, which means between the multiplication, over z to the power t, to make it positive. Then substitute each one from them, then do the rest of the calculation. So we have here exactly same idea. That is parenthesis, I don't want you confused. So w, it's 4. If you notice that it's inside, t -3, all this to the power m. M, it's what? 2. So that is equals to -12, all this to the power 2, which is equals to 144. That's nice. All this to the power z, and z 0. So anything you raise it to power 0, it's directly 1. Let me go back to this one. I'm not wasting the time doing the same exercises, and I'm sure you all okay with this, because just make sure that you try them. And let me just give you the answer fast. Try them. That's 1/9. That says try them. If you have difficulty please ask me during the office hour. If you said why, from where I got this, just let me know during the office hour. That is will be 1. So that will be finally negative 64 over 27. Now let's look at this one. This is a question, to be honest, this is related to lesson 7. But I have to explain it because some students, they like to learn more and practice more, and you might have it in Pearson. So suppose an investment doubles in value every 5 years. So this is year that investments is worth 12,480. So we can say, because that's they said this year, so that's mean the initial value is this one. How much will it be worth 10 years from now? How much was it worth 5 years ago? So if you know that it is doubles in value, it is doubles in value every 5 years. So that's important information. Now, first thing first, I highlighted the important information. I know that the exponential function can be written on the form a times b to the power x, such that I know a, it's the initial value, and b is what? It's the common difference. So here I have a, which is the initial value, which is a equals to 12,480. Now what is b? Since b is the common ratio, I can notice that the investment or an investment doubles in value every 5 years. So that means b here equals to 2. But I have to focus on one thing, that this value, it doubles in values every 5 years. So I must define x as the investment in 5 years. It doubles. That means the x value is the number of periods that the investments doubles in 5 years, definitely. So let me write this for you. This is, I can call it the number of, I'm sorry, it's very difficult to write by my mouse. The number of periods that the investments double. I'm not going to complete it. I will write invest, just a short form. Now I can rewrite my form. So that will be y equals to, what is a, which is 12,480. B, we said that the common difference, which is double in every 5 years. So times 2 to the power x. Now I need to answer the question. I have the rule that will help me to find the answer. So now, how much will it be worth 10 years? But I'm not going to substitute here by 10, because I said that it doubles in value every 5 years. So since I'm saying that, that means this 10 will be how many 5 in this 10? It's 2. For this reason, I'm going to substitute here by 2. So once I am substituting by 2, 4, 8 times 2 to the power 2, which will be equals to 4, 9, 9, 20. So that's for this part. This is the answer. How much it was worth it 5 years ago? It just, which means, I think they mean here 5 years ago, which means the previous years. But the previous years, which means it says -1. So let me just calculate it and then give you the answer. So that will be if you have, I think I missed a small number. Here is the 0. I'm sorry for that. So that's if you have to find it for 10 years from now. What about worth years ago? That means it's minus, but not -5, as I said, since we use doubles in every 5 years. So each one represents 5 years. Now that means I'm going to substitute by here by -1. So once you substitute by -1, 2, 4, 8, 0 times 2 minus 1. Once you do your calculation like this, you will get 6,400, 240. 240. So I hope this is clear for you, because actually I did not focus on this a lot in the class, because that's given in lesson 7.7, but I don't know why they mention it during the lessons from 7.1 until 7.4. But I explained it for you now in case if you need it in Pearson, because Pearson, you will have everything in it. So I want you have a strong knowledge, a very strong knowledge. Now let me solve with you, what is the volume of cube with a side length of 4 over 5. It's 4 over 5. Here it does not show 4 over 5. You know what is the volume of the cube. The volume of the cube, you will take side cube. You will take one from the side, then you will raise it to power 3. So it's given the side length 4 over 5. 4 over 5, all this to power 3. You can just distribute your power, then say 4 to the power 3, it's 64. 5 to the power 3, 125. And like that, you're done. That's for this question. The next question, it's related to physics, but I will gonna tell you the idea. Because I'm teaching you math, if I need any rule from physics, I will give it to you, because that's physics. Look at this. Now we have a light year is the distance light travel in 1 year. If the speed of light is this one, 3 times, by the way, here, this is not 3. 3 times 10 to the power 5 kilometer per second. I think they mean here per second. How long is a light year in kilometer? First of all, I need the rule that say the distance is equals to the speed over time. So distance, that's in physics. Distance equals speed over time. But what do I need here? How long? How long? That means I need the how long in a light. How long is a light year in kilometer? So what will I gonna do? I need to find this distance. So I'm going to substitute the speed that I have, which is 3 times 10 to the power 5. But keep in your mind, that's given here in second. But I don't need them in second because they gave me here in a year. So there is convert, you must do it here. I'm not gonna do it because of the physics, but this is the basic idea. Then over what? Here the time is given 365 days, which is for 1 year here. I said 1 year. But they said use 365 days for the length of the year. I'm going to change the second into years. From small to big, you are going to divide. So I'm going to divide this value by, from second, to convert from second into years. So what will I gonna do? I'm going to multiply here, divide 1 over 365 times, to convert them into seconds, times the number of hours per day, the number of minutes per hour, the number of second. Like that, I convert it. Then I will get the result. Then let's do that. I'm going to do the calculation. 3 times 10 to the power 5 over 365 times 25 times, not 25, 24, sorry. 24, 60 times 60. Which will be equals to 9.5 times 10 to the power -3. So that's the 24. So this kind of a question, as I told you, if I need it, I will give it to you. I'll solve only with you one more question, then I will stop, and then I will complete my revision, inshallah, in the next class tomorrow. So the radius of Earth is approximately is this one. Use the formula to find the volume of the Earth. So all your job, they set the radius. The radius is R. So then just substitute V equals to 4 over 3. P, I think the P is the gravity. So volume is P. What is P? They did not give me P. I'll keep P as it is, which is times pi. That is pi, by the way. I'm sorry, that is pi, but it does not show well. So that is pi, which is a 3.14 times 6.4 times 10 to the power 6. Keep in your mind all this to the power 3. So once you do your calculation, you have to focus what are you doing. So that is 3. So just do your calculation. Once you do your calculation, that will be 1.1 times 10 to the power 21 meter cube. Because I already had with you 45 minutes, I'm going to stop by this problem. Good luck, girls. Have a good day. So that's what I have for today. Bye.